Hello students, how are you all? I hope you all good. And today we are going to discuss this determinants in that before exercise number 2. So we have to discuss some of the things. It is your chapter number 4, those properties of determinants. And textbook examples, then exercise number 4.2. So today's class we are going to discuss properties of determinants, if possible textbook examples, and exercise number 4.2. okay, so before going to our class, as usual, let's close our eyes so that we'll seek knowledge of God. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Alright, let's move on to the first one. Alright, so what is first property? The first property is the value of determinant remains unchanged if its rows and columns are interchanged. So what is meaning of this? So the meaning is that if you do the transpose of this determinant, then also the value of determinant cannot be changed. So I'll take one example so that you can understand. So now this certain 1, 2, 3, 4, 5, 6, 2, 3, 4 is there. So this was there. Then what is the value of that and what is next? So now first I'll go with the service rule so that it becomes as very easy for you. So then again 1, 4, 2, 2, 5, 3. So according to service diagram, first diagonal, second diagonal, these are third diagonal. So write down this 1, 5, 4. So 1 into 5 into 4 plus another one 2 into 6 into 2, 2 into 6 into 2 plus 3 into 4 into 3, 3 into 4 into 3 according to Sarah's rule. Okay, so minus what is another one? 1, 2. This is the first diagonal, second diagonal, third diagonal. 2 into 5 into 3, 2 into 5 into 3 plus 3 into 6 into 1, 3 into 6 into 1 plus 4 into 4 into 2, 4 into 4 into 2. See here two methods, normally how we can do by using your minors using and then solving. So that I am not using, I am directly using the service diagram. So now according to that what we'll write 5, 1 into 5, 5, 5 4s are 20 plus 6, 2 6 are 12, 12 2s are 24 plus 3 4s are 12, 12 3s are. So 12 3s are how much? 36. So then minus 2 5s are 10, 10 into 3 30 plus 3 6 are 18 plus 4 4s are 16, 16 into 2, 16 2s are 32. Add these all what we get. 20 plus 24, here I will write 20, 24, 36. So 10, 4, 5, 6, 7, 8. So 80 you get. Minus another one 30, 18, 32. So again 10 you got 6, 7, 8. 80 minus 80, that is equal to 0. So here you got answer as 0. Determinant answer what you got here? 0. Let's apply, that is take the transpose of this, or we can say that rows and columns interchange and get answer and what you are going to get. Let me check. Alright, let me interchange now. So when I interchange 1, 2, 3, so this is row, I written as column. Next 4, 5, 6. Next one 2, 3, 4. 2, 3, 4. Right? So again same method, Sarah's diagram 1, 2, 3, 4, 5, 6. Right? So now multiply 1 into 5, 5 4s are 20. I'm writing directly now. So that is plus 4 3s are 12, 12 3s are 36 plus 2 2s are 4, 4 6 are 24. First one done, minus second one again 1. So 3 5s are 15, 15 2s are 30 plus 6 3s are 18, 18 1s are 18 plus 4 2s are how much? 8, 8 4s are 32. So add this out, what you get again? 36 plus 24, 60, 60 plus 20, 80 minus again 30 plus 32, 62, 62 plus 18 is nothing but 80. 80 minus 80 is 0. So from this you are understood that det A transpose is equal to det A, right? So that means the value of determinant remains unchanged if its rows and columns are interchanged. So both values you got as 0. So that this property is right. Now let's move on to the second property. I hope you all understood this first property. Let's move on to the second. Because these properties are very important, and 10 properties you have. The 10 properties you have to learn. Without learning that, it is not possible to solve examples or the exercise problems. It's very important, right? Alright, let's move on to the second one. If any two rows or columns of a determinant are interchanged, means this is two columns. Interchange this as first one and first one as second one. Okay, or first with the third, second with the third, however it is, your wish. So if you interchange columns or maybe the rows also, the first or second. So if you interchange, what will happen? The determinant value cannot be changed, value remains unchanged, but the sign of the determinant changes. Means if plus answer is there beginning, you get as minus answer. If minus answer comes, plus answer. Let me check how to solve this. So here it is 3, 11, minus 1, 5, 2, 0, 10, 3, 0. So again, use your Sarah's method so that it becomes as very easy for you. So now what I do here, just observe. First I'll find the det A. Let me think this as A and find the det A. So if I need to find it, so 3, 5, 10, 11, 2, 3. Right? So first let me find out what is answer for this. So this is your first one, this is second one, this is your third one, right? Now 3 into 2, 6, 6 into 0, 0, plus, I'm writing directly here, det A. So, and now 11 into 0, 0 into any number, 0. Now, minus 1 into 5, minus 5, minus 5 into 3, minus 15. Then minus symbol. Next, again here. 10 2s are 20, 20 into minus 1, minus 20. Next, 3 into 0, 0, 0 into any number, 0. 0 into 5, 0, 0 into any number, 0. So what do you get here? Minus 15, minus into minus, plus 20, so that 20 minus 15, 5. So you got det A is equal to 5. Now let me check after interchanging what is going to be happens, whether you get minus symbol or not. Let me check now. For checking again I am looking and I am going to write here again back. So this is your question, and now I change. I'll change this with this. Then what is going to be happens? Let me write 11, 2, 3 means what is my change? C2 as C1, C2 means C1 and C2 both are interchangeable. That is meaning of this arrow. Okay, remember that. So 3, 5, 10, minus 1, 0, 0. And according to Sarah's rule, what we need to do? Sarah's diagram, these two again write 11, 2, 3, 3, 5, 10. Okay, first one diagonal, second, and then this is third one. So what we need to do? 11 into 5, 55, 55 into 0, 0. So after interchanging, okay. So then after that 3 into 0, 0 into any number, 0. Minus 1 into 2, minus 2. Minus 2 into 10, minus 20. Right? Minus symbol. Next, 3 into 5, 15. 15 into minus 1, minus 15. Correct? Next, 10 into 0, 0, 0 into any number, 0. 0 into 2, 0, 0 into any number, 0. Right? So now what you got? Minus 20 minus of minus 15. So minus 20 minus into minus plus 15. So minus 20 plus 15 means minus 5. You observe carefully now. Value is not changed, only the sign is changed. You got sign as here minus. So when you interchange columns or the rows, you get the value cannot be changed, but the sign of that value, sign of that determinant value will change. Here plus is there, here came minus. So that is only your property number 2. Let's move on to the property number 3. Alright, let's move on to the third property. If any two rows or columns of determinant are identical, what is identical means all corresponding elements are same, then the value of determinant is 0. So example I'll show so that you can understand. 1, 2, 3, 4, 5, 6, 1, 2, 3. Now observe, in this determinant 1, 2, 3, 1, 2, 3. So this first column and then last column, that means column number 1, column number 3, both are same. So then the value should be 0. So how sir it is going to be 0? Whether it is 0 or not, we'll find. And whenever next time in your problem when you are solving, if two are identical comes, directly we can keep 0 because of this property of determinant. Okay. So what we need to do and how we need to do, let me check. You already know Sarah's diagram. According to that, we'll do now 1, 2, 3, 4, 5, 6. Second diagonal, third one. So multiply 1 into 5, 5 3s are 15 plus 4 2s are 8, 8 3s are 24 plus 6 2s are 12, 12 1s are 12 minus, now first one, 3 5s are 15, 15 1s are 15, so that 15 plus 6 2s are 12, 12 1s are 12 plus 3 2s are 6, 6 4s are 24. Now check here clearly, 15 is there, anyhow here I'll write 15 plus 24 plus 12 minus 15 minus 12 minus 24. When you remove bracket, all pluses will change into the minus. Plus 15 minus 15 plus 24 minus 24 plus 12 minus 12, that is equal to 0. So you are understood now. So if any two rows are identical or two columns are identical, our determinant value or det A is equal to 0. Okay, that is your third property. Let's move on to the fourth property. Alright, let's discuss fourth one. If each element of a row or column of determinant is multiplied by a constant k, then its value gets multiplied by k. That means, see, it is a Delta is nothing but det A. Okay, det A we can represent with the delta also. This triangle we need to read as a delta. Okay, so delta. So this delta 1 is your resultant one when you multiplied with the k. So what I'll do is, this is your delta. This multiply with some number. So let's say that this total middle row is multiplied with 2. What will happen? Let me check. So this is it. What I'll do here, it is 3, 11 minus 1. This is one example previously which you took. And this multiplied with 2. 2 5s are 10, 2 2s are 4, 2 0s are 0. 10, 3, 0. Okay. Now just find the value. This value you got previously, that det A is equal to, or delta is equal to, we can write it as answer as 5 you got previously. So let me check this answer now. So 3, 10, and here also 10, 11, 4, 3. So let me check what are possibilities and how we can solve. So now answer for this is I am thinking as a delta 1. So now 3 4s are 12, 12 into 0, 0, plus, and our 11 zeros are 0, 0 into any number 0, minus 1 into 10, minus 10, minus 10 into 3, minus 30, and minus symbol. Then first one, 10 4s are 40, 40 into minus 1, minus 40. Next, 3 into 0, 0 into any number 0, 0 into 10, 0, 0 into any number 0. So what you got answer here? So minus 30, minus into minus, plus 40. Right? So you get as how much? 10. This can I write 2 into 5? Yes. Then 2 into, what is your 5? 5 means it is delta. So now delta 1, this implies delta 1 is equal to 2 delta. So means delta 1 is equal to k delta, means if you multiply with k, you will get k. If you have multiplied, I was multiplied this total row, second row, 2 multiplied with R2. So R2 times 2 multiplied with R2. That means R2 is multiplied with 2. That is what I am saying. Okay. This is normally R2, but what I done operation here, 2 is multiplied with R2. So when you multiplied, so at last your answer of the determinant value also multiplied with 2. If it is multiplied with n number, if you are thinking that n you are going to get. So that is about this. And if it is multiplied with the same number 2 places, means 2 rows, then that becomes as, it is with n rows I'll keep here, delta 1 is equal to k power n delta, n rows. If it is 1 means here it is 1 k. If you are multiplied with k, only 1 row k power 1. If you are multiplied with 2 rows, that k power 2, 3 rows k power 3, and so on. If n rows are there, so n rows are n terms, then you can write k power n delta. Clear now? That is about your fourth property. Let's move on to the fifth property. Alright, next property is this. If each element of a row or column of a determinant are expressed as a sum of 2 or more terms, the determinant can be expressed as sum of 2 determinants. So what is meaning of this means? I'll write here example so that you can understand. So here it is like 2 plus 4, 5 plus 7, 9 plus 2, 1, 2, 3, 4, 5, 6, like this determinant is there. Then we can write this determinant as sum of 2 determinants. That means first write only this first column one, 2, 5, 9, 1, 2, 3, 4, 5, 6, plus another determinant is that 4, 7, 2, which is added 4, 7, 2, and remaining 1, 4, 2, 5, 3, 6. 1, 4, 2, 5, 3, 6. So in this way we can write, that is only the word, not more than that. Means if you are added any numbers, that number separately you can write as a determinant, and these two will be the same as it is. See, you are observed here 1 4 2 5 3 6 will be same for both. Okay, so we can express in this method. So if here three numbers are there, another row also here added, then you can write it as 3. Okay, that is about your fifth property. Let's move on to the sixth property. Alright, let's move on to the sixth property. If the element of any row or column of a determinant is added or subtracted with any of other row or column with a multiple of constant, then the value of determinant does not change. You already know this, determinant value is nothing but 5. And we need to check now what is meaning of this. Just I'll write here so that you can understand. So here same determinant 3, 5, 10 is there. What I will do here, it is add last row not required. I'll add, okay, last row I'll add with multiple of 2. So 2 into minus 1, what do you get? So I'll write here minus 1 into 2, minus 2, 0 into 2, 0 into 2. Then remaining 11, 2, 3, minus 1, 0, 0. So means what I was done, I did, here it is C1 is added with some multiple, that is a 2, that is K, and C3. Means in C1 what is our change? C1 tends to C1 plus KC3. So means it is multiplied with some constant, that value is 2, and it's C3. C3 as it is added. So that is the meaning of this. What is that? Added or subtracted with any of other row with a multiple of constant. So that's what multiple of constant, a constant is 2. So then the value of the determinant does not change. So value of determinant cannot be changed. So let me check whether it is possible or not. Whether it is possible or not to change or not. Let me check now. What is this is equal to, like, simplify also, or you can use that divide into two determinants and then find the answer also. So whichever possibilities are there, that you can use. So I'll use normal one, so that means dividing one I can use. So means separately I'll write, let me check, 3, 5, 10, 11, 2, 3, minus 1, 0, 0, plus another determinant is minus 1 into 2, minus 2, 0, 0, 11, 2, 3, minus 1, 0, 0, according to property of fifth property. Okay, so now already this value is how much, 5 plus, so value never changes, means what we required, the last one should be 0 required. How it is possible? So let me draw here Sarah's diagram for this. Minus 2, 0, 0, 11, 2, 3. So this is our first one, second one, and then third one. Let me check. Minus 2 into 2, minus 4 zeros are 0. Next, 11 into 0, 0 into 0, 0. Next, minus 1 into 0, 0. Minus another one, 0 into any number, 0. 3 into 0, 0, 0 into any number, whatever it is, 0. Next, 0 into 0, 0, 0 into any number, 0. So at last, this all 0 and you got only 5. So this is the meaning of this property. Then the value of the determinant does not change. Is there any change in this value? No change. So that is about your sixth property. Let's move on to the seventh property now. Okay. Alright, let's move on to this. If element of one row or column are multiplied with cofactors of elements of any other row or column, then their sum is 0. So it is very easiest one how this is going to be. So first Anyhow, I'll take a general one only. My delta is equal to delta or det A is equal to. So let me write A11, A12, A13, A21, A22, A23, A31, A32, A33. For this, for first row, if you take, so how to write with the cofactors your determinant, you already remember formula is A11 F11 plus A12 F12 plus A13 F13, right? So in this way we have to find out. So that what they said is first. So what is this value you have to find out. Like if before finding that what we need to do means then their sum is 0 means what I want to do here it is. So first I'll write in this A11, A12, A13 place exchange this means substitute row 1 with row 2. That means A11 plus A21, A12 plus A22, A13 plus A23. That I am doing. Then remaining will be same A21, A22, A23, another one A31, A32, A33. So anyhow now what is going to be your answer according to our property. So if two rows or columns are same then what we get answer is that determinant should be equal to 0. So what is this determinant now? So what can I write here this determinant now? So here we can write determinant as A21. So this is equal to A21 F2 F11. This cannot be changed. F11 plus A22 F12 plus A23 F13. So here let numbers whichever is there that you have to write and cofactors cannot be changed. That is F11, F12, F13 only you are going to get. That becomes as 0. Similarly what I can write? Similarly, if I change this A31, then what will happen? A31, A32, A33, A21, A22, A23, A31, A32, A33. Now, two rows are same. So, two rows are identical means that becomes a 0 that is equal to A31 F11 plus A32 F12 plus A33 F13. So, however you get answer as 0 that means the sum always should be the 0 when you interchange. Okay. So, or we can say that when you substitute the first row with the second row. So, here not exchanging, just substituting this full values here, that's it. So, that is about your seventh property. Let's move on to the eighth property. Alright, let's move on to the eighth property. If the elements of any row or column of a determinant are zeros, then the value of determinant is 0. So, you already know this determinant det is equal to 5. So what I'll do here it is just I'll take another example 3, 11, minus 1, 5, 2, 0, 10, 3, 0, right? So this minus 1 also change it to 0. So means one column completely it is 0. Then what is going to be our value? So according to this property the determinant should be the 0. Let me check. So 3, 5, 10 according to Sarah's diagram 11, 2, 3. First, second, third. Now 3 2s are 6, 6 zeros are 0 plus 11 0 0 0 into number 0 plus 0 into 5 0 0 into any number 0 minus second one 10 2s are 20 20 into 0 0. Next 3 0 0 0 into any number 0 0 into 5 0 0 into any number 0. So what you got answer at last? 0. So what they are saying it is, if any row or column completely with the zero, the total determinant should be zero. The delta becomes zero. So that is about your problem number 8. Let's means property number 8. Let's move on to the property number 9. Alright, let's move on to the ninth property. In a triangular matrix, the value of the determinant is product of the elements of the diagonals. So let me take one triangular matrix so that it becomes as very easy. 1, 2, 3, 4, 5, 2 I'll take. And remaining becomes as a 0. So this is a triangle matrix and triangle determinant I am writing here. So anything is missed? Diagonal. Yes. So diagonal down one is 0 means that is upper triangular matrix now I took. So according to our property is that this determinant will be the multiplication of only this diagonals. So what is your answer will be 3 into 2 into 1, that is nothing but 6 only your answer. Whether possible to get 6 or not, we have to check by using our Saras diagram. Let me check. 1 0 0 4 2 0 5 2 3, and again now 1 0 0 4 2 0. Sorry, this Saras diagram, right? So first one, second one, third one. 1 2s are 2, 2 3s are 6. 4 2s are 8, 8 into 0, 0. 5 into 0, 0, 0 into any number 0. Minus 0 into 2, 0, 0 into 5, 0. Plus 0 into 2, 0, 0 into any number 0. Plus 3 into 0, 0, 0 into any number 0. So at last what you got answer here? 6. So you have understood now? So whenever the triangular matrix are given, the value of determinant is the product of the elements of the diagonal. So that time, no need to go for this Saras method. Directly you can multiply the diagonal and write your answer if it is a triangular matrix. So that is about your property number 9. Let's move on to the property number 10, last property. Alright, let's move on to the last property. If a determinant has a polynomial with variable x. So here a polynomial with variable x is there, and if by substituting a in the place of x, the value of determinant is 0, then x minus a will be the factor of the determinant. So here always remember carefully what they were saying is that if you are substituted in the place of x, a if you are substituted, then the total determinant becomes as a 0 and x minus a going to be a factor. So now here a and b both are there. So what I will do here it is now let substitute x is equal to a and x is equal to b. Okay. So in one place x is equal to a, in one place x is equal to b, I need to think, then it is going to be easy for you so that you are able to solve each and everything. Okay. So first I'll take x is equal to a and I'll substitute, then you can understand what is our problem. So now if I substitute x is equal to a, what will happen? 1x as a and a square, 1a square, 1b b square. Now you observe according to our property, if two rows or the two columns are same, then the determinants becomes as a 0. So and now here x place you substituted as a, that's the reason x minus a as a factor. Okay. So another one also we'll check. So x is equal to b substitute now. When I substitute b, 1b b square, 1a square, 1b b square. So again 1b b square, 1b b square, here two rows are same, so that it becomes equal to 0. So now let me check whether it is possible to be factors or not. So for that factors purpose, how to solve this part. So it is very easy. I'll go for some other ways now so that you can understand clearly now. So first way is this. So first what I'll do here it is, so I'll do some two operations here. So the first operation I'll do here is R2 tends to R2 minus R1. First one. Second one, R3 tends to R3 minus R1. Okay, this just substitute so that you can understand. So first R1 no change, so that 1x x square as it is at. Okay, so next R2 is changes are there. So what is R2? R2 minus R1. So R2 is this, R1 is this. When you minus 1 minus 1, 0. A minus x, A minus x. A square minus x square, A square minus x square. Same method can you tell for this one? So here 1 minus 1, 0. B minus x, B square minus x square. So I hope you all understood this how to do. So these operations actually we can call it as elementary operations, and it is very easy also. So now we make 2 as 0. If 2 or 0 is there, then very easily you can find your answer. So it is factors, cofactors method I am using now. Just you can observe carefully so that you can understand. So this becomes as A11 and A21, A31. So now A11 F11 plus A21 F21 plus A31 F31. So it is very easiest one. So A11 means what do you know? 1. And remaining part will be this. What is that? A minus x, A square minus x square, B minus x, B square minus x square. Plus A21. A21 is what? 0. 0 into any number 0. A31 0. 0 into any number 0. So then just normal multiplication. A minus x into B square minus x square minus A square minus x square into B minus x. So now how to solve this part? Simplification part. So it is simplify so that you are able to get your answer. So how to do this part? Still A minus x into B minus x, B plus x minus here A minus x into A plus x, B minus x. So in both, is there any common? You find here B minus x, B minus x. So common that B minus x, what is going to be happens? Then A minus x into B plus x minus A minus x. Okay, A minus x and B minus x both are common. So A minus x and B minus x. So here A minus x into B minus x. Both are common. So what is left now? B plus x minus A plus x. So when you do this, A minus x into B minus x into B plus x minus A minus x. X get cancelled. At last you get answers A minus x, B minus x and B minus A. So now factors are A minus x, B minus x, B minus A, and still this if you take all minuses are common manner, then you can write x minus A, x minus B, A minus B. So this last one, B minus A, only this minus common here, x minus a, here minus common, x minus b, minus into minus plus, so that this is your answer. So that is about your 10th one. So at last you prove that a and b, x minus a, x minus b are factors. So that is about your 10th property, and if you have any doubts you can comment on YouTube comment section so that I can help you. I thought I want to explain full, but these determinant properties are very important. Kindly remember this one. So next class we are going to discuss textbook examples. After that we are going to solve our exercise problems. May God bless you all.